show that 6 minus root 8 over root 2 minus 1 can be written in the form a plus b root 2, where a and b are integers. So I'm going to rationalise the denominator, which means that we've got two terms on the denominator here, so I'm going to multiply by root 2 plus 1, the conjugate. Just basically taking this, copying it here, but flipping the negative to be a positive. Right, let's expand these brackets. So I've got 6 times root 2, which is 6 root 2. I've then got 6 times 1, which is 6. I've then got minus root 8 times root 2. So that's going to give a minus root 16. Now, root 16, the square root of 16 is just 4, so I could replace that root 16 with 4. And then finally we've got the root 8, or rather the minus root 8 times 1, which is minus root 8. Right, onto the denominator. We've got root 2 times root 2, which is just 2. We've got the root 2 times 1, which is root 2. We've got the minus 1 times root 2, which is minus root 2. And then we've got the minus 1 times 1, which is minus 1. Next, I need to simplify this a little bit. Now, this root 8 here, I know I can simplify root 8. Root 8 could be written as root 4 times 2, which is the same thing as the square root of 4 times the square root of 2, and the square root of 4 is 2. So root 8 is the same thing as 2 root 2. Right, collecting up like terms, I've got 6 root 2 minus 2 root 2, which is 4 root 2. I've then got 6 minus 4, which is 2. On the bottom here, we've got 2 minus 1, which is just 1. And then we've got root 2 minus root 2, which is 0. So actually my denominator is just 1, and therefore we can rewrite this whole thing as 4 root 2 plus 2.